Hey guys, so here's part 3 of the day 1 notes. Another type of measurement we're going to be talking about is standard deviation. So we've talked about the measurements of central tendency. That was your mean, median, mode. Now we're going to be talking about the idea of spread. So range is another measurement of spread, but so is standard deviation. Now on that idea of range, finding the range is helpful, but it doesn't tell us how spread out the data is between the minimum and maximum value. Basically, we can just figure out, from our minimum to maximum, here's all our data points, okay? But what about how far out from each other are they, okay? Well, how can we find the average distance of the values from the mean? So what is the mean of the data set? So here, you'll notice a little symbol here, X bar. That is the symbol to represent mean. So anytime you see that, just know it represents mean. Okay? Go ahead, I would say pause the video, try to find the mean of this little Okay, let's see what you got for your mean here. So we have the mean as, I'm going to use now X bar, because we're going to see that symbol quite a bit to represent mean. So it is 4. So remember, you add up all the numbers, divide by how many there are. There you go. Okay, so now we're going to complete the table. So I would like you guys to go ahead and find the distance from the mean and then the distance from the mean squared. So just do those 2 columns. Pause the video to do that for me, please. Okay, let's see what you got. So you take each of the value and subtract from the mean. So it is possible when we do that, we get negatives. So I think we get -3, -3, and then we do 3, that gives us -1, 0, 2, and 5. Okay. Now let's add up all of these numbers because we can see there's a total. Now if you didn't do that originally, that is okay. We're going to do that right now. So when we add up all the numbers, so we have -3, and -1, so that gives us -7. And then added to 2 and 5, that gives us +7. So -7 plus 7 gives us 0. Now here's a little thing, okay? When you do the distance from the mean and you add everything up, it will always add up to 0. Okay, so that's kind of a neat little thing. Now distance from the mean squared. So the idea is, let's think about distance, right? We really don't think of distance as a negative. Now you might also be wondering, well, okay, there's a thing called absolute value, and we can take the absolute value of numbers to make it positive. Yes, but in statistics, when you take the absolute value of numbers, it actually gives you different information about your points. So if we try to do it that way, we would get different information than what we are wanting to find here. So that's why we want to square it to give us a positive value. So when we square, we get 9. This is 9, right? We get 1, 0, 4, and 25. Okay. Now, the total there will be about 48. Of course, you just add that and put it into your calculator, whatever. Now, average, so the distance from mean squared. So we want to figure out the average. Remember, to do the average, we take our total and divide by how many numbers? So that's going to be 48 divided by, I think there's 1, 2, 3, 4, 5, 6. And I think we get about 8. Right, there you go. So now it says this average is for squared distances, okay? So the idea is we want to figure out, well, what is the distance from the mean to our value? And we want to find the average of that. So what we had to do to make it positive is square it. And as I said, we can't use the absolute value because that actually gives us different information. That's a different statistic that we can find. But we don't want it squared because we want just the value minus the mean and the average of that. So as it says, this average is for squared distances from the mean. How do we use this to find the average distance from the mean? Okay, I want you to go ahead and pause the video and maybe see if you can figure out what we would have to do here. Okay, well, let's think about it. If we have something that is squared and we want to undo a square, what do we do? Hopefully you thought of, well, square root, because it's the opposite and it undoes or undo a square there. So how we use this to find the average distance is we're going to take our 8, so that is the average square distance, and just do the square root. So our standard deviation, which we're just going to use SD to represent that, is going to be square root of 8. Okay? And then here, if you want to, and sometimes we will have to do this to really understand the idea of standard deviation, because in our head, sometimes we don't know like what is square root of 8, what that value is. But in some problems, you might want to actually take the square root of the value to get your answer. So square root of 8, that's what we would do. And actually, that would give you about 2.83. So that would be our standard deviation. Okay. So that's the measure of spread. So that is the average distance the values are from the mean. Now, using that information, there's actually a way that we can represent that as a formula, okay? So what I would like you to do is, using the information that we just did, so using the chart, so the distance from the mean, then squaring it, and then square rooting it, see if you can figure out what would be the formula for standard deviation. Okay, let's see what you got. So, SD to represent that. So now when we did the distance from the mean, we took our values and subtracted it from the mean. So we're going to do that, okay? Then we squared that information. So I take the value, and to represent all different values, I'm going to use like sub 1, sub 2, sub n, all that stuff. So minus the mean. And then as I said, we squared it, right? That's what we did in the second part of the. Then we added these values, right, because we got a total. Then x sub 2 minus, and I'm going to talk about what all these, symbols represent, so just hold on. Now, what do we need to do in order to get the average? Well, we needed to divide by how many numbers there were, right? And then how did we get rid of those squares? We square rooted. So here, to find the standard deviation, and this is the formula we use, is x sub 1 minus x, or by the mean squared, plus x sub 2 minus the mean squared, all the way to whatever's our last data point, subtract it from the mean squared, divided by how many data points you have, and then square root it. So as I said, x bar represents the mean. Your x sub 1 and your x sub 2 and x sub n, they represent your data points. And then n represents the number of data points. Okay? So that is the formula that we can use to figure out standard deviation. Now, let's do our last thing where it says, what does standard deviation tell us about a data set? Well, let's think about this, right? So standard deviation is talking about the spread of data. It kind of talks about basically how spread out, or not how spread out, data points are. So as I introduce this is a spread, a measure of spread. It just tells us how spread out the data is. So this represents when we talk about probably our like histogram and that stuff, the shape. If we have a wider type of shape, that means the data is a little bit more spread out, okay? But if it's narrow, that probably means everything's a little bit closer together. And if it's wider, that means we probably have a high standard deviation because all the values are spread out a little bit more. But if our shape of the graph is a little bit narrower, which I'm going to try to do, there we go, that's a lot better. That means we're going to have a low standard deviation because the data is not that spread out, okay? Okay, make sure you guys work on the homework assignment, and if you have any questions, make sure you contact me. I'll see you guys later.